this is the controller in the machine, right? This is all new. I rebuilt. If you get down there to the actual switch gear, all your drives are there. The PC is there. There's a variable speed drive there for the spindle. You have the power supplies. That there with the CM. Oh, see the kit in there in front of you. That's actually the controller.
Right.
That controls the machine from the PC to that. That's a buffer, and then obviously we have this. That's just the keyboard up there and the switch gear and the safety relays and all that sort of. That functions the safety relays there. Yeah. Then I wound my own transformer for that as well. I had to wind a transformer 220 volts, and I had to wind it down to. I had to put a winding on it, a secondary winding on it of 70 volts, because those drives only can handle 70 volts. They're what's called Geco drives. They're American drives.
Right.
And then in here, which is not finished yet, they have the capacitors and the bridge rectifiers to convert from AC to DC rectification in there. So I used every bit of room in the machine that I could possibly use. The whole machine had to be modified. That machine there was that machine there. They're the similar type of lathe.
Yes.
But this is the CNC, obviously, whereas that's a manual. I find it more convenient there to do once-off bits and pieces on that. If I was doing chest pieces or something on this one, very handy for doing like the Leica one. Just use chest pieces as an example.
Yes.
Or maybe some intricate turning you could do on that.
Brilliant.
Okay.
Brilliant.
And in here then, that's my bench there, which is in a mess.
No. That's clearly, you know.
Yeah. So in here then we have this is where I do my electronics. I have my microscope in here. I have my tooling in here. So basically, what I have here, I carry all spare parts here. This is all electrical spare parts, like resistors.
Yeah.
I suppose every sort of component you could possibly imagine is there, and we have LEDs. We have here. Then we have contactors. We have all sorts of stuff for switch gear again. Emergency stops, LED lights. Then here we keep all the ferrules for doing the cabling, and we do more ferrules. Then we have all the tooling for the machines here for the lathes. This is all the lathe tooling here, and the milling machine tooling. That's all the end mills and slot drills there in that box there.
Yeah.
Again, here we have variable speed drives. We have servo drives. We have power supplies, and we have PLCs up here. PLCs here. Sorry, these are PLCs. These are Mitsubishi PLCs, which I do program from time to time, do various projects with those. And I have the software for them. I have a couple of Siemens PLCs there as well. I have VFDs here as well, variable speed drives for motors. Telemecanique, or Schneider as they're now called. And we do program them and use them for various projects as well. More PCs. Here then is my tooling for the lathe. These are all my that gentleman that you just mentioned there will understand this.
Oh yes.
They're all the holders for the Dixon tool post. We have our 3 and 4 jaw chucks there. We have our tooling for the CNC lathe, the 30 International tooling there. And we have more bits and pieces here. We have screwdrivers, we have pipe cutters, we have drill bits, metric drill bits, imperial, needle files, more suction pads, not vernier calipers, micrometers, a few of them, the taps and dies. We have more taps and more taps, and more tooling for the milling machines again, and what's here, and more tooling, more of the same, and more drill bits, and that, and that's off a turret, an auto tool change turret parts of it there. This is where I kind of do my what I do, try and keep it as tidy as possible. But basically what I do here, I use my solder there and here, a soldering station here. I have my microscope there, which I'm trying to put a camera on at the moment. This microscope is going to have a camera on it, right?
Yes.
I've actually done the light part first. So I'm going to link that to my PC so I can actually observe and do rework on PCBs using this microscope. More tooling. Another cat, a larger one.
Oh, goodness me.
That's a bigger one. I just like this cigarette.
Yeah. Ah, so obviously another Jaguar.
That's another Jaguar. Again, that was made from a rim of a wheel, an LA rim, which was melted using an oil burner. You know, the oil burner that you use in the house.
Yes.
An old one of them, and I made up my own furnace. And it melted the aluminium, but it actually that was melted, that was poured around 700 degrees C. Any aluminium I melt has to be poured around 700 degrees C to get it liquidized enough and that flows.
Yes.
PCs, that's my PC there. All the software is on that then for the CNC machines.
Right.
It's out at the moment, but then we have more to it. Here then we have our electrical tools, crimpers, pliers, ferrules, strippers, another crimpers, another strippers. A lot of tools that do the same, a lot of replications tooling, but different makes, obviously.
Yeah.
And here, well, we have nothing in there really, just thermocouplings and that sort of thing. Here we have our spanners, which is there's more than that, and there's some of them, and then we have our socket sets here.
Yes.
And we have what's here. I would keep our Dremels in there. That's for engraving. That's for doing very small work. We say when we do the castings, we can actually do the fine art. But that there, you get all different cutters for that there. It's very linear slides, which I intend to put on a 3D printer at some stage. I have the 3D printer, but I need to fit these on. It's a project. That shouldn't be in there. That's rotating center for the down here. Then we've all the lathe tooling, all the clocks, the sleeves, and the drill bits and cutters and all that sort of thing. There in that one. Incredible. And here then, there's nothing in that one. There's nothing in that one. That's the communications cable for the PLCs, for the Mitsubishi PLCs, the computer.
Yes. That's
a PC from a 3D printer, spare one. And what have we got here? These are molds, silicone molds that I made for various chess pieces. I actually made those, but you pour wax into them.
Yes.
You take the wax out then, and you put it into plaster, and then you melt the wax out. And then when it's dried out perfectly, you pour your molten metal into the wax cavity, or it's called loss wax, because it's what's known as investment casting. That's my glue gun, which I found very handy. I got that there recently, and I don't know how I did without it, because it's very, very handy.
So what does that do?
That's just hot glue. It's just like glue. It glues.
Oh, right.
It's like welding, but in plastic.
Yes.
But there's a skull. It's another mold I have there for making gear stick handles from time to time.
Ah.
Yeah. I have one inside actually. I'll show you the one inside that I made. There's one inside in the thing there, yeah. So again, you pour that, you fill that with wax.
Yes.
You concrete it into plaster. You burn out the wax, pour it outward, and then let it dry, and then you fill that cavity then with molten aluminium or copper or brass. Now I haven't done copper or brass yet, because my machine won't actually get up to the temperature. I need about 1200 degrees for copper or brass. Certainly 1200 degrees for brass anyway, or for copper rather. And here we have all our tips, all the different carbide tips with all the tooling, and a box of stuff there for different tools that I have for the CNC and for the other machines.
Yeah.
And then over here, that's my power supply there, my soldering station. I've got two of those. I've got an instrument panel out of the dash of a transit van there that I'm working at the moment, trying to clean it and get it going. I think I've done it. It's on test at the moment, but that's the shell of it, which I need to put back together at some stage. And there's one I got at work there. There's one I'm going to fix actually. There's a drive there that came out of a machine at work. So I'm going to see what's wrong. That's giving an error, and it's not actually sending the signals out to the motor, or sending the signal. It's obviously a control or a control system or an IO system, an IO problem, input output problem. So I have to see what's wrong. I may have to reconfigure the parameters and then maybe just clean it off, delete everything off and reload it again, and it may work. But I got it to work. They put in a new one. We put in a new one up on that machine. Stepper motors over here, then all different types of steppers. servo. They are served. They're a DC. That's a DC servo motor. There's one there with the one there I built with an encoder on it. There's an encoder on that one there.
Yes.
And I was trying out that one there. That came off one of the old milling machines that you have out there. That I showed you. You know the one that's outside the yard.
Yes.
Well, that one came out. So I actually put an encoder on that one there, a 500 line encoder, which will work on my CNC machine.
Yes.
Here we have more of the same. It's pneumatics. I do a lot of work with pneumatics as well, like pneumatic cylinders, and I have a lot of valves and stuff like that. Maybe not so much there, but they are around the place. They're somewhere. There we have an example there of pneumatics. That's pneumatic valve there. 5 two-way and 3 two-way and 5 two-way valves. A lot of that stuff would run control those with PLCs. There's a lot of them upstairs. There's another one there that I'm working on there. I'm going to make a pick and place out. That's called a rodless cylinder. So it moves over and back that way. They have the sensor there, and as you see there, to pick up what position it's on, whether it's at the end of the cycle or not. So that'll tell the PLC, well, now it's there, so it's going to be sent back to the far side, and vice versa.
Yes.
That's. And over here then, here, pure alcohol. Can't leave this one out. This is pure alcohol, right?
Yes.
This is for cleaning PCBs. I bought that to clean the dash, or to clean the actual instrument panel of the transit. I cleaned it all first with this stuff, with this alcohol. Then I reflowed all the solder in again, and I think it has worked. It's been in, and it's looking good.
Excellent.
It's working, and it seems to work so far anyway. So we didn't do a test run on it at the moment, but that's my welding shield up there. Then I do a bit of welding, and that turns. When you're welding with that and it gets a flash, it actually turns black, but you can actually see through it. I can see you clearly now.
Yes.
But if that gets a flash, it's going to change to black, and then you can weld. So obviously the flash has some reaction with that. I'm not quite sure it works. I didn't bother looking at that one, but yeah. So over here. I used to do a lot of work with transformers. I like transformers. I love copper. I have copper here. I have a selection of copper here that I'm going to melt at some stage.
Yes.
That copper was stripped from all transformers. Now I strip the old transformers and I rebuild them. I always keep the transformers, but for instance, I have a transformer here. This is a transformer here, right? It's the iron core of a transformer. I'll just leave it down. I'll leave it somewhere even. That's the iron core of the transformer. That's the bottom piece. That's the base. That's the base top, right? This is what's called the bobbin. So what I do here, I'd rewind that.
Yes.
So let's say I wanted to run. I put 240 volts in that, and then I might put maybe 5 volts on it, 30 volts, 24 volts, 110 volts. And I can make my own transformer to suit my own needs, rather than going out to buy one.
Yeah.
And what I do, I strip all the copper from other transformers, and I keep what's it called? It's enamel type copper. There's an enamel coating on it, so especially for winding transformers, and that's very handy thing to have, because even only recently there I had to wind a transformer, very small transformer, where I wanted 110 volts, yes. 240 supply in, 110 out, to run a little motor pump, and I wound the transformer myself. The other things I do, this is the wire here. All this wire is all taken from old transformers. This wire was taken from old transformers and will be used again. My next project is a windmill, so I'll be winding transformers, or winding coils for the windmill, so that the magnets can pick and produce power. I'm not really explaining that right, but
no, that's
so anyone that understands electronics, I suppose, will understand. So every bit of that there will be used, and every bit of that came from all transformers, but it's perfect wire, and that wire is so expensive to buy. Like if you were to buy the wire like in the rolls, the big rolls, it's so bloody expensive.
Yes.
And the guy that stays with us, he's an engineer. He's electrical engineer in a hospital, and they do take out transformers from various machines.
Yes.
Such as those ones there, and this one here, an example here. This would be another one here. They take out them.
Oh yes.
That's an isolated transformer now. So you could have your 240 volts in that there, and you could have your 110 or your 200 volts and that, or your whatever, you can separate them, which is a safety issue. Like can be,
Yes.
you know, if the transformer goes, burns out, it's not going to affect this one. Plus the fact they're isolated from each other. That's the reason they're safe.
Yes.
And he would give me some of these transformers, and some of them I'd rip. Most of them I would have to rip actually, because it's highly unlikely if the ratio is correct on them that I want for any given job that I'm doing at the time. So they're all height and hang controllers, scrap height and hang controllers. They're up. One of them is off that machine out there.
Yes.
I just keep them for parts.
Yes.
And there's more transformers here. They're donut transformers. They're really no good. I don't use them. I just scrap them. I take the copper off them.
Yes.
I've stripped that one practically. There's a lot of copper taken off that one.
Yes.
That was a lot. There could have been 100 meters of copper. Maybe 150, 200 meters of copper taken off that.
Yes.
But I've still left some on it because it's a nightmare to get it off. You have to twist it round.
Oh, I
Unlike
see.
these, they just wind like a spool.
Yes.
But they're different. They're wound different. I don't even know how to wind them in industry. I don't know. But yeah. What else have we there? Then we have. Again, we have more tooling here then as well. This is more CNC tooling, more switches, stuff I don't use but is there.
Yes.
There's vices for the milling machines. Nuts and bolts here, which is bloody mayhem because I don't have them separated. I took a route into them anytime I want to get a nut or anything like that, but they're there.
Yes.
And with that, I can't work without them.
Yes.
At least if I'm short for a nut or bolt or screw, I can go there and it's usually there. I can find it.
Yes.
And I have stainless steel and I have all sorts of them. Here, in this box here, is all sensors. I keep sensors. I love sensors. I love messing with sensors. So there are all different types of sensors we have there. I'll show you how a sensor works now as well, Rob. Let me see. Or Ian. Rob, Ian.
Yes, sir.
I'm going to show you how a sensor. I'm going to show you how a sensor works. So a sensor there, right? So I have a little box in here for testing sensors.